right? Stuff like this without too much details.
Hello everyone, I'm happy that you are here for yet another workshop today, and here we will talk about censorship resistant mining, and the talk, maybe a little demo, will be driven by Elia, Filippo and Lorenzo from the Stratum V2 core team. So big applause.
Thank you. Hi everyone, I'm Filippo, and today we are going to see what is financial censorship and how it's related with Bitcoin. Then we are going to see why miners are decentralized and why this is a good thing for censorship resistance in Bitcoin. After that, we are going to explain how pooled mining work and how solo mining work, and which are the difference between them, and why pooled mining could be an issue for censorship resistance in Bitcoin. Then I will give you a brief intro of what SV2 is and the improvement of SV2 over SV1. Also some SV2 limits. Then Lorenzo will illustrate a payout scheme for non-custodial pools. And at the end, Elia will show how a typical SV2 session looks like, and if there is time, a little demo. So, the two Bitcoin fundamental properties, there are only 21 million of them, and Bitcoin is permissionless. Now, let's see what financial censorship is. Financial censorship means that you have to ask permission for spend your asset. You can have your transaction reversed. You have to ask permission in order to receive and keep your Bitcoin. The first and the last point in Bitcoin are more or less the same. Now let's see if Bitcoin is censorship resistant. There is no double spending, so you cannot have your transaction reversed. Everyone can participate, so it's permissionless. That means that there is no need to ask permission in order to spend your Bitcoin. But let's see if that's really true. In order to spend your Bitcoin, you have to publish a transaction in the blockchain. And to do that, you have to ask permission to the miners to publish that transaction in the blockchain, because are the miners that are publishing the transaction in the blockchain. So the miner want to maximize their profit, and the miner want to maximize the fee in the block that they mine. So you can spend your Bitcoin if your transaction pay an adequate fee to the miner. You can communicate to the miners. That means that you have access to internet. If you don't have it, you have a bigger problem. And no one forces the miner to not accept your transactions. This last point, let's see if how easy it is for someone to censor a miner. It's not easy, because miners are geographically decentralized in order to minimize variance in electricity costs and protect against regulation. Also, historically, we saw that mining bans are not so effective. For example, after the China ban, we observed a lot of mining activity in Germany and Ireland, and this mining activity is very likely to be China miners using VPN. So everything is okay. No one can censor miners, and Bitcoin is censorship resistance. No, because if you are not a very big miner, you want to use a pool for a lot of good reasons. And pools are a lot easier to censor than miners, because are centralized for their nature, and they are a lot fewer pools than miners. So, in order to see why pooled mining can be an issue for Bitcoin censorship resistance, we have to explain before how mining work, in that case solo mining work, and then how pooled mining work. So, solo mining. Solo mining is the act of apply a double SHA function to the block header. Check if the result is below a certain target. If it is, you mine the block. If it is not, you change the block header value without changing the meaning of the block header. And you apply the function again, and so until you find a result that is below a certain target. So how you can change the block header value without changing the block header meaning? For example, there is the nonce field that it's there just to allow mining and have no meaning at all. So you can put any value there, changing the block header value without changing the block header meaning. Another thing that you can change is the version, and another thing that you can change is the some bit of the version, of course. And another thing that you can change is the Merkle root. The Merkle root it's derived by the transaction list, all the transactions that are in the block. So if you can change the transaction list without changing the meaning of the transaction list, you can change the Merkle root and the block header value. A way to do that is using the script field. The script field in the Coinbase input, of course. The Coinbase is the first transaction in this transaction list, and the script field in the Coinbase input do not have any meaning. So you can put there any value, and changing that value will change the Merkle root, that will change the block header. Now, how miners get paid? In solo mining, miner put an address that they control as an output of the Coinbase output and get the reward, the block reward, and the fee in the block. Now, the mining pool properties are work distribution, reward distribution, and share accounting. Work distribution. If you are a miner and you are in a pool, you want to be sure that you are not hashing the same block header of another miner in the same pool that you are. In order to do that, you use that script field that I showed you in the 2 slides before. So this script field is called extra nonce and is split in 2 parts. One part is reserved for the pool and the miner cannot change it. The other part is reserved for the miner and the miner changes the value of that part in order to mine. So what the pool do? The pool assign a different pool reserved part to each miner. So each miner in the pool will have a different piece of the Coinbase. So each miner in the pool will have a different block header because we'll have a different Merkle root. Then the second thing that a pool have to do is the reward distribution. In solo mining, we saw that the miner put his own address in the Coinbase output. In pooled mining, this cannot work because if I am a miner and I'm putting my address in the Coinbase output and I find a block, I just take the reward and say goodbye to everyone else. So we need a way to redistribute this reward to all the miners in the pool. There are several ways to do that. One is the custodial pool, is the simplest. So the pool say which output put as Coinbase output to every miner, and this output is an address that is controlled by the pool, and the miner have to trust the pool to give back their Bitcoin when they ask that. Then there is the non-custodial pool, for example, peer-to-peer pool, where you have a lot of output in the Coinbase, one for each miner in the pool. So the miner do not have to trust the pool to give that back the Bitcoin, because when the block is mined, they already have the Bitcoin. This wastes a lot of block space that could be used for transactions that pay fees. And there is another way to do non-custodial pool that is with a payment pool that will be explained by Lorenzo later. Then there is the semi-custodial pool that is a pool that owns the Bitcoin for the minimum amount of time possible and can achieve it with something like on the right. This is a script that could be put in the Coinbase output with 2 branches. The first branch is a submarine swap with a lightning node that pay each miner in the pool, and the second branch is the payment pool if the first thing do not work out. Then the last thing that a pool have to do is share accounting. So in a pool you can have a very big miner and a small one. That means that the very big miner have more hash power and have to be paid more for the work that they do. So the pool have to know how much work every miner do. In order to do that, the pool assign a miner target to each miner. This target is higher than the Bitcoin target. So when the miner is looking for the solution of the Bitcoin target, we'll find solution for the miner target because it's easier, because the miner target is higher than the Bitcoin target, and the pool, knowing the miner target and all the share provide this parcel solution provided by the miner, can calculate how much each miner have to be paid. Share accounting can be done in three ways: centralized and trusted. That means that the miner send the shares to the pool do this calculation and say to the miner how much he has to be paid, and the miner trusts this number. Centralized and trustless, the miner send the shares to the pool publish in some way in a public database these shares for every miner in the pool, so the pool can see that the shares that they are providing are in that database, and the miner can also see that the amount that the pool say that the miner should be paid is the right one. Then there is decentralized that can be achieved with a blockchain, in peer-to-peer pool. It's a blockchain of shares with an higher target of the Bitcoin one. And the Braid pool use a graph of shares. So when the pool receives the share is composed by principally the time, the nonce, and the miner reserved bits of the extra nonce. When the pool receives this share, in order to check that this is a valid share, have to recreate the block header that have been used by the miner in order to mine these shares, and check if that is below a certain target. So, in order to do that, the pool have to calculate the Merkle root. In order to calculate the Merkle root, we'll concatenate the pool reserved bits with the miner reserved bits, and we'll obtain the extra nonce of the Coinbase. The pool already know the Coinbase output because have been assigned by the pool. And then the pool have to know the Merkle path or the transaction list in order to calculate the Merkle root. In Stratum v1, there is no way for the miner to communicate to the pool which transactions want to include in the next block. And this is a big issue because it's the pool that, in order to do this thing, have to choose the transactions that have to be put in the next block. That means that if someone wants to censor a Bitcoin transaction, have to attack the pool and not all the miners. In Stratum v2, we had a set of messages that allow the miner to communicate which transactions they want to put in the next block, and this is a good thing because if someone wants to censor a transaction, have to target the miners and not the pool. And we saw before that the miners are not so easy to censor. Okay. SB2. SB2 is composed by a bunch of protocols and a bunch of roles. We have the mining protocol that is used by the pool to communicate the miner server bit of the extra nodes to the miners, and it's used by the miners to send the share back to the pool, and a lot of other things. Then we have the template distribution protocol. It's used by the Bitcoin node to communicate the block header template and the transactions to the miner or to the pools, it depends. And the job declaration protocol that is used by the miner to communicate to the pool which transactions the miner want to include in the next block. Then we have the roles. We have a pool, of course it's a pool, a mining device. The mining device is the actual hardware that do the mining. We have the proxy that can be of several kinds. We can have an aggregation proxy that aggregate a lot of mining device connection in one connection with the pool. And there can be a translation proxy that translate SV1 message from the mining device in SV2 message from an SV2 pool. Then there is the template provider, that is the Bitcoin node, and the job declarator that will be explained by Elia later. Improvement over SV1, transaction selection, we already saw it, encrypted and authenticated. This disable some possible man-in-the-middle attack that were possible with SV1, so this is an improvement over SV1. Binary data format is more efficient, so this is an improvement. And SV2 is specified where SV1 is not. This is an improvement as well. Now, what is not in SV2? It would be nice to have a Coinbase negotiator protocol. This to allow non-custodial pool, so all the miner can negotiate a Coinbase. And a share accounting protocol. This will allow decentralized share accounting or centralized and trustless share accounting. Now I'll give the word to Lorenzo.